Good morning, honorable judges and fellow innovators. We are MBG Technology, representing University Dinamika Surabaya, Indonesia, at the 5th International Business and Management Virtual Innovation and Invention of Ideas Competition. Today we are thrilled to present our innovation, CaCO₃, a roof paint renovation derived from green mussel shell waste designed as an eco-friendly alternative to reduce hot temperatures in Southeast Asia. Let's start with a pressing reality. Southeast Asia contributes to nearly 19% of global mussel shell waste. In Indonesia alone, over 300,000 tons of mussels are produced. And remarkably, 70% of this ends up as shell waste. At the same time, tropical countries are facing severe rising temperatures and dealing with the urban heat island, or UHI effect, as shown by the growing number of research articles addressing this crisis. Vicious cycle. This extreme heat traps us in what we call a vicious cycle. Global warming and the UHI effect increase ambient temperatures. This heat transfers directly through building roofs, making our indoor spaces incredibly hot. To cope, people use air conditioners more frequently and for longer periods. This massive surge in electricity consumption forces fossil-fueled power plants to produce more carbon emissions. These emissions then amplify the greenhouse effect, causing ambient temperatures to rise even further. We must break this cycle. Product introduction. Our solution to break that cycle is CaCO₃. CaCO₃ is a reflective roof coating made from green mussel shell waste, scientifically known as Perna viridis. By utilizing the high calcium carbonate, or we can call it CaCO₃, content naturally found in these shells, we created a powerful solar reflector. Formulated as a water-based acrylic, CaCO₃ is specifically designed and optimized for roof applications in tropical regions. Benefits. The benefits are significant. Applying CaCO₃ can reduce indoor temperatures by up to 6 degrees Celsius. This drastically lowers AC usage, supporting energy efficiency and carbon emission reduction. Novelty, newness, and innovation. How does CaCO₃ compare to existing products? Most commercial reflective plants use synthetic materials or industrial pigments mined from the earth, which are less environmentally friendly. CaCO₃, on the other hand, sources its main material directly from organic shell waste. This not only makes it highly eco-friendly by supporting a circular economy, but it also adds double value, reducing urban heat while simultaneously solving the coastal waste problem. Novelty, unique, and creatives. Now let's discuss the uniqueness and creativity, which are categorized into economic, environmental, and social aspects. The first one is economic impact. Regarding the economic impact, our solution successfully lowers building electricity consumption, costs, and increases energy efficiency by reducing the dependency on air conditioning. Second, for the environmental impact, it significantly reduces building surface temperatures, which cuts down the use of AC, and slashes carbon emissions. Ultimately, this contributes to climate crisis mitigation in the Southeast Asian region. Finally, looking at the social impact, this innovation supports urban heat island mitigation in densely populated areas, helping us create a more comfortable and sustainable urban environment. Business and application potential. Beyond its environmental benefits, CaCO₃ also presents strong commercial potential. Our innovation is designed for application on large roof surfaces that are highly exposed to solar radiation, including warehouses, factories, logistics centers, commercial buildings, urban areas affected by the urban heat island effect. Our target market consists of both industrial and non-industrial sectors. Industrial customers include factories, warehouses, and logistic facilities that continuously seek ways to reduce cooling costs and improve energy efficiency. Meanwhile, non-industrial customers include residential housings, office buildings, schools, and universities located in tropical climates. From an economic perspective, CaCO₃ utilizes abundant green mussel shell waste as a low-cost raw material. By converting waste into a value-added product, we can reduce material costs while helping building owners lower their cooling energy consumption. This creates a scalable business opportunity that can grow from small-scale production to industrial manufacturing, particularly across Southeast Asia, where both shell waste and rising temperatures are significant challenges. Technology readiness level. To evaluate the maturity of our innovation, we adopted the Technology Readiness Level, or TRL, framework. As shown in this roadmap, the development process begins with fundamental scientific understanding, progresses through concept formulation and validation, and eventually reaches large-scale commercialization. Currently, CaCO₃ is positioned at Technology Readiness Level 2, which means the formulation of concept stage. At this level, the scientific principles have been identified, and the conceptual design of the technology has been developed, based on existing research findings. This stage provides a strong foundation for future prototype development and experimental validation. Production flow. To guarantee quality, our production involves a strict 10-step process. It begins with the collection, sorting, cleaning, and sterilization of the waste shells. After drying to achieve low moisture, we mechanically crush and screen the particles. We then formulate and homogeneously mix the biocoating, apply it to the test panels, and finally conduct rigorous ambient temperature curing and performance evaluations.
Cool shell biocoating. Reflective, protective, sustainable.
Intellectual property. To support future commercialization and protect the value of our innovation, we have developed a comprehensive intellectual property strategy for CaCO₃. First, we identify patent opportunities related to the reflective biocoating formulation, the use of calcium carbonate-rich waste shells, the manufacturing process optimized for tropical climates, and the specific particle size and binder composition used in the coating. Second, we plan to protect the CaCO₃ brand identity through trademark registration, including the product name, logo, and associated branding elements. Third, the visual appearance of our packaging and product containers can be protected through industrial design registration. Finally, all supporting materials such as technical documentation, process diagrams, infographics, videos, and educational content are protected under copyright. Together, these intellectual properties protection strengthen the commercial potential of CaCO₃ while creating long-term competitive advantages in the sustainable building materials market. To conclude, our CaCO₃ biocoating transforms green mussel shell waste into a reflective roof coating. It reduces building temperatures by up to 5.49 degrees Celsius, boosting energy efficiency while supporting sustainable waste management. Thank you, and these are our references.